Hello and welcome to another one of D's ADD videos. Today we're going to be looking at graphs of sine and cosine. First thing you should always do with these is do the grunt work. What's the amplitude? Amplitude is 5, comes from right there, absolute value of this number. Then the frequency. Well, the frequency is this B value right there. If you don't know what I'm doing right now, watch the concept video for sine and cosine graphs. Then we got to do the period. The period is going to be 2 pi over the frequency, and in this case we said the frequency was 3. And then the phase shift, you set 3x minus pi over 4 equal to 0 and solve. So 3x equals pi over 4 divided by 3, x equals pi over 12. So that's the phase shift. Okay? So now let's get what the new fundamental cycle is going to be. So what we do is we set up the inequality of 0. If you want to make it equality, that's fine. Just find out where the beginning and the end is what we're doing here. So by doing this, it tells me that I can literally solve for my fundamental cycles beginning and end. Again, fundamental cycle is just one complete sine graph. And then you add pi over 4. And then the common denominator is 4, so it's 8 pi over 4 plus pi over 4 is 9 pi over 4. Alright. And then divide by 3. Sorry if I'm a little slow, it's 3 o'clock in the morning. And then that's going to be 3 pi over 4. Okay, so if we did this correctly, the difference between these two should equal the period, which in this case is 2 pi over 3. Let's test that theory out. So we got 3 pi over 4. Always good to check your work, make sure you're on the right track. You want to get a common denominator here. So you multiply this by 3, so you multiply the top by 3. And then here you get 8 pi over 12. 4 goes into the top twice. 4 goes in the bottom 3 times. So yes, that is the period that we got up here. Okay? So now we're going to add the period times 1/4. We need that measurement to figure out what the individual points are going to be for that fundamental cycle, the first fundamental cycle we're looking at. In this case, we got pi over 6. So if I take pi over 12 and add pi over 6 4 times, I should get 4 different answers for my, in this case, since it's sine, it's going to be the axis, peak, axis, trough, axis. And I'll show you what I mean by that here in a second. So you start at the first point, which was this pi over 12 here. And that's going to be the beginning. I'm going to underline it. Plus. And then when you add these, that's going to be 2 pi over 12. So it's going to be 3 pi over 12 here. Plus. Now here's the next point. And that could be reduced to pi over 4. And then 2 pi over 12 again added is going to give me 5 pi over 12. No reducing going on there. Plus 2 pi over 12 is going to be 7 pi over 12. Plus, and then 2 pi over 12 is going to be 9 pi over 12. And that should have actually been, what, 3 pi over 4. When we reduce this, indeed, we do get a 3 pi over 4. 3 goes into 9 3 times, and 12 4 times. So those are my main players. So let's plot the points. We're almost done. So we start at pi over 12. The next point is going to be 5 pi over 12. 7 pi over 12, and 9 pi over 12. Okay, for sine, the first point is always on the axis. The amplitude here is going to be, what was the coefficient up there? 5, I think. 5. So we're going to be going up 5, up to 5, and down to negative 5. So it goes up to here, down to there, back down. So there's your first fundamental cycle. Of course, it does continue in both directions, but for your purposes, if you're asked to graph one cycle, you are done. Alright? Now, all the intercepts are going to be added to some multiple of pi over 6, as you can see. So, make sure you practice these. Watch the second video in which we'll do this problem. If you want to try it on your own before you watch the video, please do so. And then the final one we'll do a video on this one, okay? So, I hope I've cleared up any confusion you might have. Practice, practice, practice. They're going to get a lot harder than that one. So, you need to be ready. Thank you and have a nice day.